Hello. So in this video, I'm going to discuss another linear algebra problem. The question came in 2024 Iit Jam. The question says that let's say V is a subspace of some vector space over C, whose every element, non-zero element is non-singular. Then you have to prove that dimension of V is less than 1. So here is the question you can see. So let's see the solution. So without loss of generality, I am assuming that V is not trivial subspace. That is, V is not 0. Because if it is 0, then dimension of V is obviously 0 and we are done. So we are assuming that let's say V is not 0. And we are choosing two elements M and N from V. So let lambda is an eigenvalue of N M inverse. So we know that if lambda is an eigenvalue of some matrix, let's say A, then Ax equal to lambda x for some non-zero column vector x. So here I am using that, we will get n m inverse x equal to lambda x. Fine. So in which implies that determinant of n m inverse minus lambda in equal to 0, right? So if I take m outside, I'll get determinant of m times determinant of m inverse minus lambda in equal to 0, which implies that determinant of n minus lambda m equal to 0. Fine. Which implies that n minus lambda n equal to 0, because we know that 0 is the only element of V having determinant 0, because every non-zero element is non-singular. So every non-zero element cannot have determinant 0, which implies that n equal to lambda m. So we got that if we choose any two element from the V, then I can write one as the scalar times some other matrix. So every element can be written as some linear combination. That's why dimension is 1. That is, dimension is 1 less than dimension is 1.